What's up, everybody? Welcome back. In this question, we have to determine the equation of the inverse of this quadratic, y equals negative 3x squared plus 24x minus 42. Now, to find the equation of an inverse of a quadratic, the quadratic has to be in vertex form. If you remember from the lecture videos, unfortunately, this is in standard form. So we're actually going to have to take this quadratic first and convert it to vertex form, and then from vertex form find the inverse. So we got to complete the square on this. So basically we could take out a negative 3 from the first two, so we'd have x squared. 24x divided by negative 3 is minus 8x, and the minus 42 we'd keep outside. Right, so here we take half of negative 8, which is negative 4, and then square it. So this would be plus 16 minus 16. This is minus 42. Remember, if you're factoring something out, when you do the b over 2 squared, right, to get the 16, it's always with this b value in the brackets, not the original b value. So we wouldn't take half of 24, which is 12, and square it, which is 144. It's always what's remaining in the brackets. So plus 16 minus 16. And then from here, what do? We have to take out this negative 16. But when we take it out, we've got to multiply it by what's in front. So negative 16 times negative 3 gives us positive 48. This is minus 42 here. And then this here will always be a perfect square trinomial if you did the b over 2 squared part correctly. So this is going to be x minus 4 squared. This number is always half of this number, or the square root of this number, and then the sign is always the same. So if this was plus, this would be plus as well, but it was minus. So this is minus as well. And then 48 minus 42, that is just positive 6. Right? So took this quadratic in standard form, converted to vertex form, and now we could find the inverse. Basically what we do is we rewrite this, but we switch the x and the y. So we would rewrite this up here. So this is like step 1, complete the square. Now step 2, find the equation of the inverse. So switch the x and the y. So x equals negative 3 y minus 4 squared plus 6, like that. Okay, and then from here we just have to isolate for the y. So bring the 6 over, so we'd have x minus 6 equals negative 3 y minus 4 squared, and divide both sides by negative 3, like that. So we have x minus 6 over negative 3 equals y minus 4 squared. And then from here, square root both sides to get rid of this exponent. So we'd have y minus 4 equals the square root of x minus 6 over negative 3. And bring that plus 4 over. So we'd have the square root of x minus 6 over negative 3 plus 4 equals y. So if you want to write this nicer, proper notation, basically the inverse, that's the inverse notation if you remember, is basically equal to this right here. So it's the square root of x minus 6 over negative 3 plus 4. And this is going to be plus or minus. Right? So they're just asking for the equation of the inverse. You don't really have to graph this. If you were to graph it, the way I would do it is I would set up a table of values for the quadratic after we have it in vertex form. Put the vertex in the middle of the table, pick 2 points to the left, 2 points to the right, and then just switch the points and make a new table for the inverse and then just plot those points. This is basically going to be a sideways parabola. But they didn't ask for that. They asked for the equation of the inverse, and that's it right there. It's the square root of x minus 6 over negative 3 plus